Today, we are diving into Python. It's a programming language that seems so simple on the surface, with code that's easy to read, but it scales up to solve some of the most mind-bendingly complex problems in the world. So let's dive in and see how it all works.
It sounds like the beginning of a joke, right? You've got artificial intelligence, cutting-edge biology, and the actual nuts and bolts of the web. These are three completely different worlds, each one tackling huge, massive challenges. But believe it or not, there is one powerful thread that ties them all together.
And there it is, Python. It's the incredibly versatile language humming away behind the scenes, making all of this amazing innovation a reality.
So, why Python? I mean, what makes it the universal language for pretty much anyone working with data today? Let's take a look. This quote from RT Insights just nails it. Python is not a one-trick pony. It handles the whole assembly line of data. You can use it to grab data, to clean it up, and all the way to building APIs. And APIs are basically the secret messengers that let different pieces of software talk to each other. It's the whole package. So let's peel back the layers a bit. All that incredible power we're talking about, it's all built on a foundation of ideas that are actually, well, surprisingly simple. These are Python's fundamental building blocks.
Okay, let's start with something we do all the time, putting text together. Here, we're just taking two little strings and merging them into one sentence. The magic wand that makes this so clean is called an F string. It looks simple, and honestly, that's the whole point. Making code readable is one of Python's absolute superpowers. So at its core, an F string is just a super easy way to slot variables into your text. But that same simple tool you use to say hello can also be used to generate these huge, complex, data-driven reports. It's a perfect example of Python's entire philosophy. Keep it simple, but make it powerful.
And here's another one, another core building block, a list. We start off with a list of job skills, and then we just add Python to it with this little command, .append. And just like that, in 2 lines, we've created and then changed a collection of data.
So a list is basically a container, but the really important word here is mutable, which is just a fancy way of saying it's changeable. You can add things, remove things, shuffle them around whenever you want, and that flexibility is what makes lists absolutely essential for managing data.
Okay, so we've got our basic building blocks, right? Our bricks and mortar. But what happens when you need to do something really specialized, like, I don't know, statistical analysis or machine learning? Well, that's when you open up Python's incredible power toolkit.
And this is where Python really shines. You don't have to reinvent the wheel. If you need to wrestle with huge data sets, you grab pandas. Doing really heavy-duty math? NumPy's your friend. Building an AI model? You use scikit-learn. And for really specific fields, like computational biology, there are even libraries like BioPython. Each one is like a superpowered tool designed for one specific complex job. All right, we've seen the building blocks and we've seen the toolkit. Now let's put it all together and see how this stuff is used to solve some absolutely fascinating problems out in the real world. Our first case study takes us to the super intense world of competitive chess. Someone built a system using machine learning to recognize what the board looks like during a live broadcast. But there was a problem. AI models, well, they can make mistakes. So this right here shows a great concept they call human in the loop. This little interface, built with Python, lets a person check and confirm that the AI is seeing the board correctly. But what happens when the AI starts getting it wrong a lot? This is a classic problem in machine learning called model drift. You can think of it like this. Imagine you trained a self-driving car only on sunny days. The first time it rains or it gets foggy, it's going to struggle, right? It's the same idea here. The real world changes, the lighting, the camera angle, and suddenly the model that was trained on the old data just isn't reliable anymore. So how do you catch this drift before it causes a problem on a live broadcast? Well, this is where Python scripts are doing some serious detective work. They're constantly analyzing the data and comparing it to the original stuff the model was trained on. And look at this plot. See how the new data on the left, that red blob, has a completely different shape from the original data on the right? That is Python basically screaming, hey, something's wrong here. The world has changed. And here's the beautiful solution. A Python system automatically cooks up and emails this performance report using a cool visualization tool called Grafana. The developers get an instant alert that the model's accuracy is dropping so they can retrain it before it ever messes up a broadcast. It's a perfect automated monitoring loop, and Python is the engine driving the whole thing. Now, for our second case study, we are taking a huge leap.
We're going from the chessboard straight into the biology lab. Here, Python is being used to tackle one of the biggest questions in all of science. What even is aging, and how can we measure it? So, meet PyAging. It's a highly specialized Python library built to analyze what are known as biological aging clocks. These are biomarkers in our cells that can guess an organism's true biological age, which can be way different from how many birthdays you've had. And notice it says GPU processing. That means it's using the same kind of heavy-duty power that runs high-end video games to just blaze through unbelievable amounts of data.
So what kind of data are we talking about? I mean, this is seriously complex stuff from deep inside our cells. It's looking at how our genes get switched on and off, how our DNA is packaged. It's just wild. Essentially, Python, armed with a specialized library like PyAging, is giving scientists the tools they need to find that tiny, crucial signal of aging that's buried in all that biological noise. This is truly science at the absolute frontier.
Wow. Okay, so from tweaking simple text all the way to decoding the secrets of aging, we've seen just how incredible Python's range is. So the big question is, how can you get started on your own data journey?
If there's one thing to take away from all this, it's this. Think of Python as the ultimate Swiss Army knife for data. It's got the simple, everyday tools, but it also has these highly specialized instruments for taking on the toughest challenges you can imagine.
And you know, the best part is you can start learning for free, like right now. Places like Kaggle, Coursera, and Free Code Camp have amazing, hands-on ways to build your skills. So whether you like learning by doing projects or following along with video courses, there's definitely a path for you.
We've seen how a simple list of items can lead to a system that keeps a chess AI honest, and how joining two sentences is the very first step on a path to decoding our own biology. The tools are out there, they're accessible, and the potential is just immense. So really, the only question left is, what problem will you solve next?